Hello, today I will be showing you a hill climb search technique. But before I go into hill climb searching technique, we need to know the landscape of a search. The landscape of a search is usually used in terms of local search techniques. If you want me to make videos on the other different forms of local search techniques, please hit me up with a like and a subscribe. And comment below what videos or what techniques you'd want me to make videos on. Okay, moving on to the landscape. On the y-axis is the objective function. On the x-axis is the state space. State space includes all the possible states of a problem. And objective function is a value that measures how good a state is for our search or how bad a state is for our search. As you can understand with the name hill climbing, it means we are looking for positive values or greater values. So, we will only be considering maximas here. Okay, moving on. This point is the global maxima. This point is the local maxima. This point is a flat local maxima. And this point is a shoulder. Why is this the global maxima? This point is the global maxima because you can see that this is the highest point in the entire graph. Why is this point the local maxima? Respective to its sides, these sides and this side, we can see this is the highest point. And why is this a flat local maxima? Because also respective to its side, it is also the highest value. This is the shoulder because respective to this side, it is higher, but respective to this side, it is lower. Now that we are familiar with the terminologies, we will move on to a brief description of what hill search climbing actually is, and then we will move on to the algorithm. Suppose this is our current state. In the small little red dot that you can see, we'll make it a bit bigger. The small little dot is our neighbor. We will compare this current state and this neighbor, and we will see which one has a higher objective value. If the neighbor has a higher objective value, we will move on to the neighbor and repeat the process until we reach a maxima. Suppose we reach this point. Okay. Now when we reach at this point, we will check with its neighbors, which is this one. And then we will see that the value of the objective function here is less than the current state. So what will we do? We will reject this value. We will look for another neighbor. Suppose we come and look for this neighbor. Here. This neighbor will also have a value of objective function which is lower than our current state. So, we will assume that this is the highest possible value. It will get stuck at this maxima, which is the local maxima. To reach this global maxima, there are various methods, but our algorithm will not focus on reaching a global maxima, rather it will focus on reaching a local maxima. Now, moving on to the algorithm. This is our algorithm. Function, hill climbing, problem. This problem here is the graph input. Returns a state that is a local maxima. Input, a problem, and the local variables are current, which is our current state, and neighbor, which is our neighbor state. Current, make node initial state problem. This means we will make a node using the initial state of the problem, and we will initialize it in current, and we will continue looping until we find a value which is a local maxima. What will we do in this loop? Neighbor, a highest value successor of current. We will find a child of current which has the highest value. If the value of the neighbor is less than the value of the current, then return state current. That means if the value of the neighbor is less, we will return the state and we will say that we have reached a local maxima. Otherwise, we will initialize current with the neighbor value and we will continue doing this loop. I hope this video is clear about hill climbing search, and if you want to know how to find the global maxima, leave a comment below. Thank you.